Alright, welcome to BKW Physics. We're going to look at the motion of these three vehicles. And what I want you to think about as you look at this motion is what would a velocity time graph of each one look like? So we have the sudden impact vehicle here. And this sudden impact vehicle is one of the ones you wind up and then it takes off on you. And I want you to notice it's starting from 0 and it's speeding up. The next thing we want to look at is the big pumpkin tow truck here. And this truck is starting from a fairly high speed and slowing to a stop. And the last one I want you to look at is the Jeepster. Love that sound. Which travels along at a constant speed pretty much forever until the batteries run out. So if we spin up to the whiteboard here, we have three graphs started. And what do you think? I guess I started with the sudden impact, so let's start with that. What is the velocity time graph going to look like for the sudden impact? What is happening to the speed of this as time goes on? It's increasing. So if we said that it started at a speed of 0, which it did, and then it was increasing, we could say that the graph, that's supposed to be linear, I tried to draw it straight. We could say that the speed was increasing going uphill. In comparison, what did the big pumpkin do? Started fast and slowed down, still linear. And then the Jeepster, what happened with the speed in that situation? So whatever speed it was going, let's say it was going that fast, it just kept going that fast, horizontal, flat, linear. Now, in the previous session we talked about taking the slope of these different types of graphs. So what if we were to take the slope of this graph? I just picked this one for instance. I could have picked the one before it. Slope is the change in y over the change in x. Our y variable being velocity, our x being time. And this is something that you're just learning about today for the first time. When you take a change in velocity over a change in time, what you are doing is you are finding acceleration. So in the reference table, acceleration is the change in velocity over time. But there's more. There's more. You can do one other thing which is really important. What if I said, look at this green area underneath the line. Look at that space underneath there. What if we found the area of that space? And how do you find the area of a triangle? 1/2 base times height, length times width. You got the idea. So what's the base thing? Well, that's a time. And what's the height thing? That's a velocity. Don't worry about this. This is just a number anyway. It's just a constant, okay? So what does that remind you of? Velocity times time.
Distance.
Thank you. Distance. Catch you next time. Physics.